All right, so let's start. So this is about population. So by definition, ano ang population? So ano ang isang population? Probably magtataka kayo, we're skipping kasi supposedly it's species tapos population. Pero we'll proceed with the population. We will cover also species. Okay. Ano yung population? Kesha, Miss Valencia.
Ay, lang population po, for me, it includes yung isang community.
Okay, isang community. Yeah.
Yung,
Go ahead.
It includes the numbers po, total number ng isang community po.
Okay. So, thank you, Miss Valencia.
Thank you po.
Okay. How about Sir Darwin? Populations. Population.
Hello, sir. Can you hear me po?
Yeah.
A group of individuals of the same species that are, ano ba ang term doon? Interbreeding in a same area or given area po. Yun po yung idea ko for population.
Population. Okay. So, let's see. So, yun yung ano natin sa populations. All right. So, when we say population, so nakita natin dito sa image na to, we have, these are elephants. So, elephants na nasa isang lugar. So, by this picture, we could say that this is a population of the elephants. Now, kapag sinabi nating population, by definition, so that is group of individuals of the same species living in the same area. So, ano yung mga qualifiers natin? So, they should be a group of individuals na dapat pare-pareho yung species na nakatira sa isang lugar. So, we can refer that as a population. So, as it is reflected in our image dito sa screen. Now, this is a hypothetical population. Assuming that all of this, yung mga nakikita natin na dots, they represent an individual organism. Now, yung blue naman, the blue line, it actually defines the population distribution. So, or the area in which the population occurs. So, meaning, etong mga to, considering there are individual organisms of the same species, they are distributed in this area. So, makita natin dito, medyo varying yung kanilang distribution. Now, factors to consider when we talk about population is actually abundance. So pag sinabi nating abundance, that is the number of individuals in the population. So abundance is a function of two factors. It considers population density. At the same time, it also considers the area in which the population is distributed. So the population size naman, or the abundance, is a function of the population density and the geographic distribution or the area that is occupied. So we could see this as a formula pag sinabi natin about sa population size. So that is a function of density and area. Now, in computing for population density, kino-consider natin yung number of individuals per unit area. So, this is another image. So, meron tayong mga naka-shade na blue dito. So, dito sa natin, makita natin, iba-iba yung population density ng bawat area. So, let's assume na halimbawa yung bawat cell dito ay, let's say, it's 1 meter squared. So, 1 meter squared, kunwari, itong size ng bawat cell. So, makita natin that the cell 1 has a different population density as compared to cell 2 and as compared to cell 3. So yung cell 3, we can see 0 yung kanyang population. So it means the area is unoccupied. While for cell 1 and cell 2, yung cell 2, 2 individuals. So kung titignan natin, ang magiging population density niya is 2 per meter squared. While for this, dito sa cell 1, it is 5. So 5 per meter squared. So that's how we compute for the population density. We have varying distribution. So yung population distribution natin, it comes into 3 ways. So we have, of course, the random, the uniform, and the clump. So yung random, it is dispersed anywhere dito sa area. We also have the uniform. It means may equal distance yan. At meron din tayong clump. So ito yung common natin na nakita na distribution ng mga different species. So where can we possibly see itong mga say itong uniform species, a uniform distribution? Saan natin to kadalasan makikita? How about Sir Chris?
What?
Yung uniform.
Saan nga ba? Wait lang, sir. Parang I have no idea.
Iba-iba.
No
Meron
idea,
tayong,
sir.
di ba, meron tayong iba't ibang ecosystems.
So desert, sir.
Sa desert, yeah. Sa desert. What else? Let's say yung mga ano natin, forest. So yung mga forest natin, somehow, there are distances. May mga distance yan from one tree to another tree. Especially kung magkakapareho ng species present dun sa area. May distance, may equal distance kasi may nutrient requirements sila. So hindi sila pwedeng mag-join. Yun yung visible din yan, di ba? Pag ginagawa yung mga different plantations, yung mga coconut plantation, and even in the natural area, ganun yung distribution din nila. So how about for clump? Ang question natin is bakit nagkakaroon tayo ng clump na distribution? Miss Ria.
Ano sir, wait lang po. Sa mga ano sir, kapag nagtanim po tayo, for example, for the seeds na ilalagay natin sa, di ba pag ilalagay natin siya sa taniman, yung may minsan magkukumpol sila ganyan. Tapos pag mag-grow yung plant or yung species, magkakasama. Ganyan.
Sir, ako sir sa
Okay.
clump. Parang,
yes,
pwede ba sa
Sir Chris.
microorganisms, sir, yung forum sensing?
Yeah, possible. Yeah,
Yeah.
pwede yung microorganism. Sige, go
Yung
ahead. Sir Chris.
forum sensing, sir, yung nagsisignaling sila para magkumpulan.
Okay.
Yung
So
quorum
ano
sensing.
yung so this is reflected sa microorganisms, you can see that. So sa seeds na tinatanim, pero ano yung pinaka-factor bakit tayo nagkakaroon ng clump? The main factor is actually, yes, Sir Neil.
Habitat heterogeneity, sir.
Okay. So habitat heterogeneity. So that's correct. That's one. So ano yung meron natin sa habitat? So it's actually the resources. So yung availability ng resources. Halimbawa, kung wala yung resources na to doon sa area, dun sa certain habitat na yon, of course, lilipat yan. So magsasama-sama yung mga same species on those areas na nandun yung resources na kailangan nila for their resources for food, for their energy. So yun yung primary reason bakit tayo nagkakaroon ng clump. So yes, nagkakaroon tayo din ng clump doon sa habitat heterogeneity kasi if there are patches of land, patches of habitat, of course, yung distribution ng ating mga species ay in patch din. Okay, so habitat heterogeneity, it comes in different factors. Pumapasok din yan, of course, yung mga anthropogenic activities natin, kaya tayo nagkakaroon ng habitat heterogeneity. Kasi in reality, at the natural sense, supposedly, wala tayong habitat heterogeneity. However, nagkakaroon tayo dyan because nagkakaroon ng intervention, nagkakaroon ng hiwa-hiwalay yung mga habitat. Actually, meron akong isang activity later that is related to that sa habitat heterogeneity. Okay, so yan yung ating mga distribution. Now, considering na ganito yung distribution natin, another factor to consider in population is, of course, the species movement. So yung movement ng ating mga individuals in a certain space, we call it as dispersal. So although the term dispersal is most often refers to the more specific movement in the individuals away from each other. Now, when a individual move out of a subpopulation, we call it as emigration. And when an individual moves from another location into a subpopulation, of course, we call it as immigration. So these are the things that we are considering when we talk about population. And when we talk about population, there are different methods to study yung population natin. So I'll just be sharing the most common na ginagamit natin. So marami tayong ginagamit pagdating sa biodiversity assessment. And when we'll be talking about biodiversity assessment, we deploy different methodologies. So gumagamit tayo ng transect line, gumagamit tayo ng quadrat, depending on ano yung mga gusto nating kunin na data from the site. Now, but the most common thing is we do sampling. So yung sampling, that is the most accurate way of determining the population size. So pinaka-basic, bibilangin natin lahat ng individuals in the habitat. So yan yung pinaka magandang gawin. However, if there are some logistics and economic concerns pagdating sa pag-conduct ng ganitong mga research, so gumagamit tayo ng sampling. So doon ang gagawin natin is we'll just pull representative data or representative animals or representative individuals dun sa area at yun yung magre-represent for the whole area. However, ang pinaka-main consideration natin dito is we have to remove the bias kapag gagawa tayo ng ganitong klaseng research. So for immobile organisms such as plants, as for very small and slow-moving organism, pwede tayong gumamit ng mga quadrat. So a quadrat is a way of marking off square areas within a habitat, either by sticking out an area with sticks and string or by the use of wood, plastic, or metal square placed on the ground. So itong quadrat presented in your screen, this is the very conventional way. Ito yung yun yung ginagawa natin pagdating sa traditional way of doing quadrats, yung maglalagay tayo ng mga pegs, tapos gagawa tayo talaga ng square. But now, with the advent of the Geographic Information System, so yung GIS, ito na yung ginagamit natin ngayon. So it doesn't necessarily that you have to create, if you have the coordinate of the area, ganun na lang yung gagawin mo. I'll be sharing an experience. When I did my biodiversity assessment on birds, so instead of a quadrat, it's a combination of transect line, at gumawa ko ng I use actually circular plots considering yung radius kung hanggang nasaan yung mga bird. Now, in each plot, instead of me going to the area tapos maglalagay ako ng mga pegs ko. So what I did is I used my maps. So yung mga map ko, I plotted my coordinates. So dun sa ginagamit ko na lang yung phone. So I use my phone. You could use also your GPS. At sinusundan ko na lang kung nasaan ako. So I assume that this area, kapag nakarating ako dun sa point na yon as seen in my map, so yun na yung magiging point ko at dun ko sisimulan yung biodiversity assessment. Now, so sampling is one important factor, one important thing to consider kapag magko-conduct tayo. Kasi, especially if we have a large habitat, we cannot sample the whole area. Hindi natin magagawang ikutin yon, especially if we also have time constraint. Yun. So, and different species, they also require a different method of sampling method. So, iba-iba yung ginagamit din natin. Another is also part of my dissertation. Nag-ano din ako sa mga amphibians. So, for amphibians, what I did is I reduced my circular plots. So I use the same area. Pero nireduce ko na yung plot considering yung geographic range, most probably of the amphibians doon sa area. Now, paano ko kinonduct ng sabay? Meron kasi tayong time element. So, titignan din natin kung kailan tayo magsasample, kung kailan natin gagawin yung study. So, for the birds, dahil yung mga birds, may diurnal sila. So, meron tayong umaga, meron tayong late afternoon. So, titingnan natin kung kailan sila marami. Kasi you cannot sample, magkakaroon ka ng bias if you will sample your data during, let's say, yung mga mainit na, let's say, 12 noon to 3 p.m. Madalang sila because they also rest. So, when I did my sampling for birds, I went to the area as early as 5 a.m. kasi abangan mo sila. Tapos yung akin namang dahil diurnal nga sila, so yung late afternoon. So I will start at 4 p.m. hanggang 6 p.m. Now for my amphibians, dahil panggabi yung mga amphibians, so nag-start naman ako for amphibians at 7 p.m. onwards. Now, since I have different sites, para mag-remove yung bias, kasi the longer that you stay in the area, the more species that you will count. So to remove that bias, nagkaroon tayo ng time element. So halimbawa, from my one point, I will limit my counting at a particular, what I did is 10 minutes. So after 10 minutes, all of the species, after 10 minutes, I will move to another point. So mag-start na naman ako ng 10 minutes. So to remove the bias. So this is how we do sampling for populations. So those are the mix and match methods pagdating sa sampling natin. Now for plants, iba din yung tinitignan natin for plants. So for plants, as seen dito, we are using quadrat. Ang tinitignan naman kasi natin sa plants is, aside from the individuals, we look into the cover. So percent cover doon ng isang halaman, doon sa area. Now, the quadrat, it is always relative to the size of your sampling area. Kung masyadong malaki yan, so you also have to adjust the quadrat, the number of quadrats, the size of your quadrats. It's always relative to that. Ngayon, ang ginagawa din natin dito, when we sample a certain area, yung iba ang ginagawa nila is fishbowl method. Let's say they will create a grid. Balikan ko lang yung image natin kanina. So, ang gagawin nila, it's a sample lang to. So, let's say for this grade, ang gagawin is fishbowl method. They will put numbers on this, tapos they will pick. So, para ma-randomize siya. So, halimbawa, to represent my habitat, I will use, halimbawa, 10 quadrats. So, yung gagawin ko is, I will do a fishbowl method. So, para mapili ko yung mga quadrats na titignan ko. So, yun yung ginagawa nila. Yung iba naman, I think ginagawa ito sa forestry, they cluster. They cluster the quadrats. So from one quadrat, bubuo sila ng mga maliliit na quadrats para makuha pa nila yung mga sample nila doon sa area na yun. So that is sampling. Now, the very common technique for in doing such population research method is the mark recapture technique. I know you have heard this already. So, ito yung ginagawa for mobile population. Siyempre, ang gagawin natin, hindi naman natin pwedeng, lalo na kung ang goal natin is for conservation, huwag naman natin kunin lahat ng mga sample doon sa area unless you need a specimen. But, ito ang ginagawa is you capture, you mark, then recapture the individuals. So we have a certain formula in computing for this. So yung gagawin natin dito, so ika-capture natin, tapos pagka-capture, lalagyan natin ng ima-mark natin sila depending on what you need to do or what marking that you would want na maglala siya sa other people, other ecologists. They tend to tag them. Yung iba sa nails, yung iba sa tail. But of course, ang gusto natin gawin dito when we do the mark recapture technique, pag nag-mark tayo, it should not be that invasive. I mean, not to the point that it may be detrimental to the health of the species. So we have a certain formula for this, but I will not discuss it into detail. Yung kung ano yung how are we going to compute for it. Now, when we talk about population, syempre hindi mawawala yung demography. So pag sinabi nating demography, that is the statistical study of population changes over time. So ano yung mga factors ng demography? We have birth rates, we have death rates, and we have the life expectancies. So yung demography natin, it can be presented in various ways. So one is the life table. So sa life table, nakapresent dito yung birth and death rates. So if the birth and death rates are equal, so the population is stable. However, if the population size will increase, if births exceed death rates, the population will decrease if birth rates are less than death rates. So kapag mas marami ang nabubuhay ng mga species over sa namamatay, so of course the population will continue to increase. So vice versa lang yan. Now, it is also in that life table where you can see yung life expectancy. So yung life expectancy, that is the length of individuals remain in the population, which impacts yung local resources, reproduction, and the overall health of the population. So yan yung mga nakikita sa ating sa life table. So dito sa isang example natin, so this is an example of a life table of Dal Mountain sheep. So we can see the number of dying, the number of surviving, the mortality rate, at the same time yung life expectancy at a certain age interval. So this is an example of a life table. Nabanggit dito yung ating mortality rate. So our formula for mortality rate is mortality is equal to the number of individuals dying over number of individuals surviving. So times n. So this is our mortality rate. Now, yung ating population, it could also be presented to survivorship curves. Who could still recall yung ating mga survivorship curves? Anyone? Okay, so yung survivorship curves natin, it actually present the number of individuals surviving in respect to the percentage of maximum life expectancy. So meron tayong three types ng survivorship curves. We have the type 1, the type 2, and the type 3. So survivorship curves. So tingnan natin. Okay. So dito sa type 1, so it is exemplified by humans. So dito, yung mortality, it is concentrated at the end of the maximum lifespan. So ito yung ang example is exemplified by humans. So madalas makita ito sa mga, of course, sa mga developed countries, humans and also for those animals na meron silang inaalagaan yung mga animals. So of course, kung provided yung food ng animal, kapag provided yung maganda yung habitat ng animal, let's say sa mga zoo, so mas mahaba yung survivorship curve na. But most commonly, humans are type 1. So kita natin na most naman sa mga humans nabubuhay mataas yung survival rate. Tapos pagdating dun sa dulo, dito na nag-vary. So nasa N yung mortality ay nasa N. Now type 2 naman, so they are exemplified by birds. So as seen in this, ito naman straight line. So ibig sabihin nito, the straight line, it describes a constant mortality rate from birth to maximum age. So it describes, for instance, yung survival ng mga birds. So ibig sabihin, as you move from sa age, constant yung number of mortality. Okay. Then lastly, we have the trees. So dito naman sa type 3, so trees are examples of type 3, yung mga species under type 3 survivorship curve. Dito naman, it indicates, so you can see here, na mataas yung mortality rate at the early stage. So at early age nung isang species ng, let's say, ng halaman, so mas mataas yung mortality. However, if they surpass that age, so ang mangyari, so baga few yung magsusurvive. At the same time, at the end of their life expectancy, bababa yung mortality. So these are the survivorship curves. So we have type 1, type 2, and type 3. Now, talking about population again, so nakaano na tayo. So we talk about demography, we talk about life tables, we also talk about the survivorship curves. This time, we'll talk about the life history. So pag sinabi nating life history, ito yung mga events, series of events doon sa lifetime ng isang species. So pinag-uusapan dito how the resources are allocated for growth, maintenance, and reproduction. So life history traits affect the life table of an organism. And yung life history, it is already genetically determined and it is shaped by the environment and the natural selection. So ito yung totality ng buhay ng isang organism. So we have here, importante i-consider pag pinag-uusapan yung life history ay yung energy budget. So all of the organisms, they require energy for their growth, maintenance, and reproduction. At the same time, yung energy then yung limiting factor in determining an organism's survival. So ibig sabihin, kailangan i-budget ng isang organism, ng mga species, yung kanyang energy. So dapat balance yung kanyang energy with respect to the use of energy for metabolism. So yung energy na gagamitin niya for reproduction, yung energy for gagamitin niya for parental care. So all of this has to be considered. So, di ba, ganito, probably could exemplify this by humans. So, sadaling analogy kapag humans. Of course, kapag nawawalan tayo ng energy, the tendency to maintain that balance, we eat. So that is same is true with the organisms. So kapag na kulang sila ng energy, so ang gagawin nila is napagod sila. Ang gagawin nila is they will hunt for food. So yun. So yung mga halimbawa, yung mga aso natin sa bahay, kapag of course dahil yung mga domesticated yung mga aso natin sa bahay, they know that we will provide them food. So ang gagawin nila is, 'di ba? Tatahol sila or kumbaga they will as if they are crying or they are begging for food. So yan yung mga ginagawa ng ating mga species, yung mga organisms. That is for them to maintain their energy. Kasi yung energy nila is needed for their daily activities, for their metabolism in particular, and for other purposes. So of course, we use also energy sa parental care and fecundity. So fecundity, that is the potential of a certain organism, so reproductive capacity of an individual in a population. So fecundity describes how many offspring could ideally be produced if an animal or individual has as many offspring as possible, repeating the reproductive cycle as soon as possible after the birth of the offspring. So very much related ito. So yung reproductive capacity natin dun sa parental care. So pag sinabi nating parental care, it is how the organisms take good care of their offspring. So may mga species na walang mga parental care. Example are mga fish. So yung mga fishes natin, different species of fish. Kapag kasilang ng mga bata, yung mga yung mga fingerlings, yung mga fish, maliliit na fish isda. So ang nangyayari is lang yan. So wala silang constant parental care. Unlike for those na say yung mga lion, yan, meron silang mga parental care kasi they really take good care of their offspring. Yung mga kangaroo. Yan. So yung timing natin for reproduction is also important. It also affects yung species survival. May mga species tayo now na if an organism reproduce an early age, of course, mas mataas yung chance niya na makapag-produce ng offspring. However, this is at the expense of the growth and maintenance ng mismong organism na magre-reproduce. Now, for those organisms na at the later years yung reproduction nila, mas mataas yung fecundity or yung ability, yung capacity ng organism na to provide parental care. However, there's a risk that these organisms will not survive at the reproductive age. Itong mga offspring. So kasi, di ba, as an organism grow old, nare-reduce din yan yung energy. So, iba din yung nagpo-provide ng, iba yung, genetically speaking, it will affect yung health ng offspring. So, that is visible, kung makita nyo visible yan sa mga human beings. Mas madali kasi yung exemplification if we talk about human beings. So, kapag at the later years na ipanganak, di ba, parang may problema doon sometimes there are some problems pagdating doon sa bata. Yung mga halimbawa, yung mga menopause baby, may mga notions na ganun. But the good thing about reproducing at the later year, of course, they can provide that kind of parental care. Now, considering their reproduction, yung mga species natin, they have also different reproductive events. So yung mga species we have some species that they only reproduce at a particular lifetime, once in a particular lifetime, tapos mamamatay sila. So such species use most of their resource budget, yung energy nila, during a single reproductive event. So sacrificing their health to the point that they will not be able to survive. So meron naman mga species na they can reproduce repeatedly during their lives. So some animals are able to mate only once per year but survive multiple mating seasons. So of course, particularly yung mga species that they have to carry their offspring for a certain period. So human beings, of course, 9 months. Yan. So that's the last maximum 9 months. So yeah. So these are the variables when we are talking about life history. Now, yung ating environment, they also set they have this, the environment can also provide limits sa ating population growth. So yung ating population, it has different age structure, the number of proportion of animals in respect to different age classes. So that is age structure. Yung population, it can be divided into 3 ecological important age classes. We have the pre-reproductive, reproductive, and post-reproductive. Now, yung population growth, it is dependent on 4 factors: birth, death, immigration, and emigration. So births, of course, yung births at saka immigration, yan yung dahilan kaya nagkakaroon ng increase in population. And deaths and emigration, yan yung dahilan naman for the population to shrink. So this is the formula that we use when we are referring to the change in population. So that is births plus immigration minus deaths plus emigration. So yeah, so that is very easy to understand. Now, yung ating population growth, there are different growth curves naman dito. We have the exponential and the logistic growth. So who can differentiate the two? Exponential and logistic curve. I call Sir Darwin. Sir Darwin, try to differentiate the two.
Hello, sir.
Yes.
In terms of ano po sir, yung kung ano pong based po sa nakikita.
Yeah, you could explain it based the figures natin.
For the exponential growth, as far as I can observe po, as time passes by, the population size also increases. If tama ang nakita ko dito sa exponential growth. For the population size naman po, as time passes by, the population size also increases. Although for the logistic growth, I think population size is limited by the carrying capacity. So parang meron pong specific na hanggang dito ka lang pwedeng lumaki. Kapag na-achieve mo na yun, kahit na we can say that population size is proportional to yung pong as time passes by, if na-hit mo na yung roadblock sa carrying capacity, subside na po yung population size kahit po mag-move forward na po yung time. Yun po yung na-observe po.
Okay, thank you, Sir Darwin. All right. So we have 2 growth curves here. So yung ating it shows yung yung population size over time. Now, dito sa first exponential growth, tama yung interpretation ni Sir Darwin that yung as we move across time, yung population size is increasing. If yung conditions are always favorable. Ibig sabihin, nandyan yung food, nandyan lahat ng environmental conditions are good, walang nagugutom, the resources are infinite. We have all the resources. So, of course, kung nandyan lahat yon, yung mga resources na yon, and every aspect is favorable to the growth, survival of an organism, the population size will continue to increase. So this exponential growth curve is also known as J curve. So as reflected by the image here. So it's shaped as J. Now, dito naman sa logistic growth, it provides you in real scenario, of course, our resources are not infinite. So, naubos yung ating mga resources. So, dito naman sa logistic growth, it tells you that as long as there are resources, the population size over time will continue to increase. However, if we reach the capacity of a certain area to provide all the resources, yun yung carrying capacity natin, your population size will now decline, will start to decline. Madalitong i-explain in microbiology. Kasi yung mga microorganisms natin. So, if we have a Petri dish, makita natin at first ay, biglaan yung dami ng microorganisms sa isang Petri dish. Now, kapag yung food, yung agar, of course, maubos yan. So kapag unti-unting naubos yan, bababa yung population. So that is how we can do an analogy for logistic growth. So dito papasok yung konsepto ng carrying capacity. So, ibig sabihin, in a certain habitat, meron lang maximum number of individuals yung kanya lang isupply. Kayang supplyan niya, yung habitat na yon, kaya niya mag-supply ng resources sa mga organisms na nandoon. So, meron tayong maximum number. And we call that as carrying capacity. Okay. Now, the carrying capacity, this is the population size which represents the maximum population size that a particular environment can support. So this is called, ang symbol na ginagamit ay K. So ayan yun. So this is your carrying capacity. So ibig sabihin, kapag ang dami ng organisms, yung population size, nag-increase dyan, it exceeds now the carrying capacity. The tendency is it will stagnate, then it will fall. Bakit mag-fall? Kasi may starvation na nangyayari. Hindi na kaya ng environment na yon or ng habitat na yon na ibigay yung mga pagkain or yung mga resources na kailangan niya doon sa area. So mag-fall na yung population size over time. So ganyan yung mangyayari that is the concept behind carrying capacity. Now, yung ating population, sabi nga kanina, we have some limits. So, kailangan ma-regulate yung population. So, the environment can regulate yung ating population. So, we have two types of regulation. So, we have the density-dependent regulation, and we also have the density-independent regulation. So sinasabi that our nature, yung ating environment, it can regulate the population growth in variety of ways, in which yung mortality, yung birth rate will be affected. So meron tayong one, density dependent regulation. So these are biological in nature. So this includes yung predation, and intraspecific competition, excuse me, accumulation of waste and diseases such as those caused by parasites. However, kaya siya density dependent, kumbaga kung kapag dumating yan, depende yung mortality rate doon sa dami ng population. So that is density dependent regulation. Yung density independent naman, these are usually abiotic in nature or physical or chemical in nature. Ito yung mga mortality, it influence the mortality of a population regardless of the density. So these include weather, natural disasters, and pollution. So we have a specific example here. So an individual deer may be killed in a forest fire regardless of how many deer happen to be in that area. So its chances of survival are the same whether the population density is high or low. So the same holds true for cold winter weather. So ibig sabihin, yung density independent siya kasi it does not consider kung gaano karami yung nandoon. So halimbawa, yan yung example natin dyan. So may forest fire. So regardless kung gaano karami yung deer na nandoon, there are some individuals that may die, that may not be weak to that kind area, hindi sila nakapag-move. So that is density independent regulation. Now, another way of regulating the population, may different ways din tayo. So may different ways din to interpret yung regulation ng on the ground. So we have top-down regulation at saka yung bottom-up regulation. So yung top-down regulation, ang gagawin dito is you will remove the top predator. So of course, kapag na-remove yung top predator, mawawala yung sorry, mali. So in control of a population by predation. So ibig sabihin, you will put a predator in the area. So ang mangyayari, halimbawa, gusto nating kontrolin yung dami ng certain species. So ang gagawin ko, kung hindi nag-exist yung predator doon sa area, ilalagay ko yung predator. So that is top-down. So it means you put the top predator of that organism, of that species, para makontrol yung kanyang population. Kasi kung wala siyang predator, it will proliferate. Pag-proliferate yung dami nun. Now, yung bottom-up regulation naman, kokontrolin mo siya kung you will control the population doon sa start ng food chain. So basically, food yung kokontrolin mo dito. So halimbawa, gusto mo kontrolin yung population again ng isang species, for it to be regulated, ang tatanggalin mo naman ay kung ano yung kinakain niya. So ibig sabihin, kapag nawala yung pagkain niya, of course, magugutom sila and they will reduce their population. So these are our ways of regulating the population, particularly sa population growth. In the area, meron tayong tinatawag na K and R selected species. So yung mga K selected species, these are those species that have stable, predictable environments. K strategists tend to maintain their populations at a more or less constant level close to the carrying capacity. Na yung R selected species naman or R strategies, they have a large number of small offspring. This strategy is often employed in unpredictable or changing environment. R strategies, they can survive or operates in maximum reproductive rates in harsh, unstable environment or during habitat disturbance while there is only a little competition exists. So ito, These are species. It actually differentiate. It differentiate your R strategies over your K strategies. So yung environment, ang mga star strategies, they can survive yung mga harsh environment as over those K strategies. So yung typically, yung AR strategies, they have small body size as compared to the K strategies. Yung lifespan ng mga R strategies, they are small. At the same time, short yung generation time nila as compared doon sa K strategies. So age at first reproduction, it is at their younger age. However, for K strategies at the older age. So itong table na to, it explains the difference of R strategies and K strategies. So yung mga human beings, they are belong to what group? Okay, so we belong at K strategies. Now, yung mga R strategies natin, dalasan ito yung mga insects natin. Now yan yung, those are some factors. Those are what we have discussed. Yan yung factors that actually influence yung population dynamics natin. However, there are some what we call stochastic processes sa isang area. So ito yung mga stochastic processes na to, they still influence yung ating mga yung population dynamics or yung fecundity, yung birth rate and all. So we have two types here. We have the demographic stochasticity at saka yung ating environmental stochasticity. Now yung ano natin, so yung random variations in births and death rates, there's a random variation in the birth rates and death rates that occur in a certain population per year to year. We call it as demographic stochasticity. So yung mga variations natin sa birth rates at saka death rates. So ito yung mga factors na it occurs in a certain population that at random. Okay? Environmental stochasticity naman, ito yung mga random variations in the environment that directly influence rates of birth and death at the environment naman ito. So, yan yung mga halimbawa, biglang let's say for this season, supposedly we have say longer winter. So however, yung mga say yung mga let's say mga organisms that are not into longer winter period, of course, affected yung birth and death rate nila. So these are the factors that occurs randomly in the population. So these are the factors or variables that we are dealing when we speak of the populations of different species. Okay. So I would like you to ponder on an item. So please go to our eskwela account. So sa eskwela account ninyo. Okay. I raised a question there. Ang topic natin is, wait lang. Okay. So how understanding carrying capacity can help in the conservation of populations. So this is the question that you need to ponder on. So I would like everyone, siguro we could answer that in 15 minutes. So let's back, we'll be back at 1:30. Ay, anong oras na ba? Sorry. 2:15. And I would like you to answer yung question na to in the PSA as well. So then pagbalik natin, so we have Via and Miss Via and si Miss Via to discuss. Tama ba, Via? Ikaw yung mauna.
Yes.
Okay. So to
Sir,
talk about dun
restricted.
sa study on the regarding sa population. So just go to your eskwela account. Yung sa PSA eskwela. Okay, so I was reading your responses. So before we proceed with Miss Villa's report, so who could enlighten us more doon sa question that I posted? Parang i-expound pa yung sagot niya. How about Sir Neil?
Sir, practical lang naman po kasi po yung ano po, yung tanong, understanding the carrying capacity. Of course, in order for an organism to survive, it needs the necessary factors. For example, food, shelter, and other things for him to survive. Kailangan niya po yun. Now, if the environment cannot provide that, there is a tendency that the population of the organism will be extinct, or depending on the, for example, meron pong competition in survival of the fittest. So it is very important to have the knowledge on carrying capacity so that the population will become stable. So that's my idea, sir, about the question.
Okay. So, yeah. Tama yun, Sir Neil. So, kaya ang topic natin na kasunod is actually on the species interaction. So, doon natin makikita kung paano nalilimitahan yung population considering yung species interaction. But it is important for us to understand yung carrying capacity nila so that we know, let's say for a certain habitat, kaya pa ba ng habitat na to na suportahan yung resources? Ay kaya ba ng habitat na to na buhayin pa or kaya bang suportahan yung dami ng organisms na meron dito? So that is very important, particularly for us human beings. Napaka-importante niyan because example na lang natin for, let's say, for NCR. So for NCR, I think there are only just 3 green spaces na present na lang sa area. So because of that, hindi na kayang suportahan nung lugar in terms of resources, kumbaga at naturally occurring, hindi na kayang suportahan yung dami ng populasyon doon. This is same is true in Boracay. So what happened in Boracay? So sa Boracay, 'di ba, nagkaroon ng I mean 6-month na closure ng Boracay just for it to recuperate from the damages. Kumbaga, it already reached the maximum. Kumbaga, lumampas na siya doon sa maximum limit. Kaya nagkaroon tayo ng deterioration, particularly on doon sa natural resources na meron doon. There are actually a lot of wetlands present in the area. However, hindi sila na-maintain. Okay, so thank you for sharing your answer, Sir Neil. So this time, let's listen to Miss Via. So I'll be sharing your presentation. So once it's kapag ano na siya
Nag-next.
naglag din ako. Kapag ano na rin siya, kapag na-present na siya, so nag full screen presentation mode, you could start. So kasi automatic na magmo-move yung ating mga
So
yung
ano na siya, sir? Naka 20 seconds each na siya niyan.
Oo. So automatic yung ano natin, slides. Okay?
Yes. Sige, sir.
Okay. So parang buena mano si Miss Via dito sa ating reporting na in this kind of reporting. So let's start. Pag nag-slideshow na. Okay?
Okay. Wow. So, good afternoon, class. Good afternoon, sir. Good afternoon, classmates. I am Violin Santos, and I'll be providing an article entitled How Ecological Feedbacks Between Human Population and Land Cover Influence Sustainability. So, if you have any idea about what I am talking about, it's good, but if not, it's fine. So, introduction, it is estimated that the Earth's biocapacity is unable to meet current demands, which begs the question, is a sustainable future possible for both humans and the environment? Papaisip ka, sustainable nga bang future natin for this one? Okay, so for the author's perspective, he said that there exist human population projections and models of agricultural expansion or land use change patterns. However, the ability to combine feedbacks and concepts of population growth and land use change into a simple dynamical model in a unique feature that allows us first to generate realistic predictions and second to evaluate alternative scenarios. So as we move forward, we will talk about this one. Okay, so there is a general consensus about this one, and in most cases, civilization collapse in which whether from volcanic eruption, soil degradation, drought, or resource exploitation. The inability to change perceptions and habit is thought to be responsible for the collapse of many civilizations. And for example of this one is the Natufians of Southwest Asia, in which they experience a population collapse. So bakit nga ba nangyari ito? Anong nangyayari? Bakit nagkakaroon ng ganong scenario? So, today, the focus is placed on agriculture to feed the growing population. However, often neglected are the ecosystem services that supply agricultural system like soil fertility, nutrients, water provision and purification, genetic biodiversity, and etc. And in turn, many agricultural systems taking resources from natural land and growing little to nothing in return. Basically, paano masusustain ng agriculture or ng environment ang mga pangangailangan ng tao kung hindi naman tama ang paggamit nila sa ating agriculture or sa ating land environment or what, like for the pagtatanim and all, and hindi sila pantay, like yung iba gustong tanim pero hindi naman dapat. And then as we can see here, the article provided a method in which this is a conceptual diagram of the model. It depicts three land variables: the productive or natural, semi-natural land, intensive agriculture, and unproductive degraded land. Nag-provide sila ng model para maipakita kung ano ba yung mga nangyayari or yung feedback ng mga ng human population for that for our sustainability. So their analysis is they dictate that population growth and land cover change, in which they group a model parameters, the proactive and reactive measures, human-driven and nature-driven. So the result is first, business as usual. Most simulations reveals that the business as usual scenarios doubles agricultural area over the next century while decreasing natural and semi-natural land. Sinabi din nila na merong alternative scenarios. By looking at alternative scenarios, they can gauge what is truly driving the system by model parameters that are driven by human decisions or practices, especially those that govern resource consumption and demand. They also said that we have their perception bias, in which an anticipated result of the model relates to how the collective human population perceives the value of land or resources. yun, kapag perception, we have the perception bias, the alternative scenarios, and business as usual. And as what I've mentioned earlier, we have the proactive versus reactive measure, in which proactive measure involves a decision that causes a change in either human population or landscape dynamics, whereas reactive measure responds to changes in the system. And their discussion is in the attempt of the drivers of population change and measure of sustainability. Their model demonstrates that insufficient productive natural and semi-natural land could be responsible for future declines in human population. In many cases, the system follows the same initial trajectory over a range of parameter values, making it difficult for individuals to assess. And also, they said that the decline in the human population predicted by their model follow a similar trend to that documented following the collapse on Easter Island, wherein the population grew as resources were abundant until the land was degraded beyond its capacity, creating a population overshoot and decline. They also said that the population estimate in the business as usual scenario of their model fits with the range of projections by the United Nations. However, the decline in human population is caused by an increase in mortality as a result of malnutrition. And then, when they consider the three categories of land cover model, like for the productive natural land, the semi-natural land, the intensive agricultural land, and the degraded land, the conversion of this to agricultural land turns out to be counteractive to sustaining populations in the long run without adequate natural land to supply ecosystem services. That is not to say that food is not critical. We need food to maintain the population. However, this work, along with a growing body of literature, raises issue with the current view of large-scale monoculturism and suggests a refocusing of food production, one that aims to increase yields and environmental integrity. When it comes bias as naman in land evaluation, as I've mentioned earlier, meron silang consensus that agricultural land is both sociologically and economically more valuable, despite being a current excess of agricultural land, not considering the unequal distribution of food and resources. And their conclusion is applying that model with feedbacks between the human and earth systems allows us to use information from the past and expand on it through the foresight of projection. The model allows us to recognize when resources are being depleted beyond the ability to replenish, and offers a way of testing an array of changes to system that would not be possible otherwise. Thank you so much po. Sir, grabe naman yung yung 20 seconds each slide. Grabe, parang to?
Natawa din ako.
Parang wala man akong na-discuss or wala man akong naintindihan sa sinabi na. Grabe yung 20 seconds.
Yeah. So they're using this kind of format in Japan. So it's Pecha Kucha. 20 slides and 20 seconds. So ginagawa nila to. Actually, I'm applying this also to my students now when they do reporting. It's because I want them to ang pinaka-rationale kasi when we present sometimes, halimbawa sa mga studies na ganyan, sometimes we need to pick the most essential topic that could explain the totality of the whole study. So ginagawa ito sa Japan because 'di ba iba yung ng mga Japanese people, they really into time. So ayun. So it's it's Ben Amano si
Sobra yung parang, oh my God, nag-introduce pa lang ako, nag-next. So, bilis ng 20 seconds. Akala ko.
Yun. So, it actually, the topic, it's important. You introduce the human ecological context. Though, population, though I'm expecting more of the, let's say, animal or plant population, but human is still population, and humans are part of the environment. So, importante din we talk about this. Pag human-environment interaction, medyo malapit sa akin yan because that is environmental science. And tama yung introduction mo actually. When you introduce the topic, they presented yung perspective na is it the environment that influence the people or it's the people that influence the environment? So meron tayong mga ganyan na school of thoughts. Ang una is yung nabanggit doon sa parang the environment that determines kung ano yung ways and means ng human beings. We call it as environmental determinism. At kapag after that, another school of thought is yung environmental possibilism, wherein yung environment, siya yung nagdidictate, yung tao yung nagdidictate, nakaka-affect sa ating environment. But now, the new context on looking into the environment is actually on the human environment interactions. So dito sa pinakita mo, I think they did some modeling. So they compared yung parang they projected if the practices today will still affect yung population. Tama ba? The agriculture and the population.
Yes.
Makakapag-provide pa, let's say, yung food production, will it provide doon sa existing population? And based doon sa model nila, yung existing pa rin na practices nila in terms of agriculture, it still fit doon sa area over time. However, yung kanilang mortality, it's not really on the food, but on the malnutrition. So kumbaga, iba yung concern in terms of doon sa limit, doon sa population. It's now actually on the health of the humans. Tama ba yung ano ko? Tama ba? So, so any comments dito sa pinresent ni Via? Pwede kang uminom.
Sir Darwin, good luck. Charot.
So, yun yung this is very important. Hindi ko to pinapagawa para may katuwaan tayo, but importante nowadays that we need to present our studies in a manner that people will really understand it. Yun yung parang, kasi iba yung ng mga tao. Iba yung, nowadays, iba yung pick nila sa mga topics. So, kumbaga, we have a very short attention span. Mas umiikli siya eh. So mas umiikli yung short attention span, mas umiikli yung attention span natin. So buwan naman lang si Miss Via.
Sir, actually kung gagawin mo nga din yan, sir, ngayon, lalo na through online, very helpful siya kasi nga din sa attention span natin na konti lang. So ang mali ko lang, dapat pala, hindi ko na siya detailed na gano'n. Yung kung ikukwento ko dapat, maano na gano'n. So, yun.
Yeah. It's a learning process. Lahat naman nabibigla sa yeah. Nung talagang words talaga eh. Hindi na nga humihinga.
Parang nagra-ramp na, sir, nung nagmandang gitna na.
Yeah. Pero, di ba, nagising ka, di ba?
Oo, gising po.
Yeah. So, I think, Sir Neil, you would like to say something?
Hello, sir. Sir, ngayon po ba kami magpipresent, sir?
Hindi, sir. So, tayo?
Okay po.
Dalawa lang.
Sige po. Thank you po.
So, we have...
Sobrang bilis eh. Akala namin kami na rin.
Yeah. So, ginagawa ko talagang pinapagawa ko to sa mga students because para matutunan din nila na kung paano po mag-prioritize ng info. So, I did this among my bio students when we talk about envi policies and laws. So, I distributed some of the international laws tapos pinresent nila. So, in this manner. So, same scenario. Of course, meron talagang parang nag-rap. So, meron talagang, mabilisan. Pero the important here is, yun nga, sabi ko, we have now to prioritize the information that we will provide. Tsaka minsan kasi, another thing, kaya ganito na rin yung ginagawa ko. Some students, hindi kasi nila nalilimitahan yung mga presentations nila. Minsan tumatagal. So, Ayun, so thank you, Via. At pwede ka nang uminom para sa ating discussion. So any reaction sa ating any questions to Via, yung baka you would like to ask her, yung mga baka hindi niya na-discuss doon sa, dahil mabilis yung topic, hindi niya na-discuss. Sige, ako na lang magtatanong. So, Ms. Via, I'm curious about doon sa proactive and reactive approaches. So, we are talking here doon sa mga policies, ba?
Yes, sir.
So, it means yung mga proactive, they compared yung mga approach na they preempt the impact rather than waiting for the event to happen, then dun pa lang magkakaroon ng policy regarding that. Tama ba?
Opo, ganun siya. Lalo na sir, ang pinaka-ano nila yung sa mga land or parang yung, for example, yung human-driven natural land degradation, yung mga ganung scenario yung pinoint out nila din sa proactive and reactive measures. Pero, tama po kayo sir.
Okay. So, thank you. Thank you, Ms. Via. All right. So, si Sir Darwin, later, mapapakinggan natin kung gaano kabilis mag-rap si Sir Darwin. Okay. All right. Let's proceed to our topic for today. This will be very, very short in a way kasi species interaction, we've been studying this since elementary. So familiar na familiar tayo pag sinabi nating mutualism, commensalism. So I think nakatatak na sa atin itong mga to. So we know them already. But I will provide some, probably kung hindi nyo pa narinig, it will be a new information pagdating sa species interactions. Okay. All right. So we'll talk about species interaction. So, of course, pag sinabi nating species interaction, this is the interaction between species or species of the between same species and different species. So we have two major species interaction, yung predation at saka yung herbivory. So predation, that is the hunting of prey by its predator. Now yung herbivory naman, it is same with the predation. However, it's focused on the plants. So usually insects and plants, animals and plants. For organisms to prevent yung pagkaroon ng itong predation and herbivory, nag-create sila ng mga defense mechanisms. So yung defense mechanisms against predation and herbivory, it includes various types. So meron tayong mechanical defenses. So for halimbawa sa mga halaman, they provide thorns para hindi sila meron silang thorns para hindi sila makain or lumayo yung mga insects sa kanila. For some, meron tayong mga hard shells. So hard shells on turtles. Now, meron din tayong chemical defenses. So yung chemical defenses, it includes yung pag-release ng toxic chemicals, then pag-release din ng mga pheromones. So pheromones, we know this, familiar tayo dito. Halimbawa, yung mga ants.
Ay, sir. Meron ba?
Yes.
Ay, sir,
I'm sorry.
meron ba?
Sorry, Chris, sorry.
Ay, sir, meron po tayo, meron ba tayo? Alam ko meron tayong pheromones.
Yes,
Meron
we
ba?
have, yes.
O, attract
Yung
naman.
human beings have pheromones. So ito yung the scent that is familiar to you usually. Halimbawa, yung mga loved ones natin, kumbaga, alam natin yung amoy nila.
True.
So, yeah, so that is because of the pheromone. So pheromones for animals, ginagamit din nila yan para as defense mechanism.
Okay.
So yung mga ants, ginagamit din yan for survival. Now, physical defenses, of course, nagkakaroon ng change in body shape or coloration or nagka-camouflage sila. So if you have seen a stick insect, hindi mo talaga siya mahalata na isa siyang insect. So, kasi mukha talaga siyang stick. So, another is yung behavioral defenses. So, kapag may predator, so you flee. The organism flee or they use mimicry. So, dito tayo mag-dwell more sa mimicry because this is very interesting. So, there are different types of mimicry. We have the Batesian mimicry, the Mullerian mimicry, the Emsleyan or Mertesian mimicry. So, yung Batesian mimicry, yung harmless species, it imitates the warning coloration of a harmful one. So, ang gagawin nito sa Batesian mimicry, gagayahin niya. Halimbawa, merong isang organism na, let's say, red siya. Kapag nag-red yung color niya, ibig sabihin, dangerous siya. So, that is, i-imitate niya para matakot yung mga ibang organism sa kanya. Meron din tayong Mullerian mimicry. So, multiple species share the same warning coloration, but all of them actually have defenses. So, ito yung ginagawa naman, same warning colorations. I will show some examples later. Last naman, a deadly prey mimics a less dangerous one. So, for an example of sa Batesian mimicry, ito. So, yung image natin sa A, this is a poisonous coral snake. Now, itong snake na to, it imitates the color of this poisonous one, itong non-venomous scarlet king snake, para as defense mechanism. So, yan yung ginagawa nila. So, this mimicry is named after H.E. Bates. Now, Mullerian mimicry naman, it was named after by Fritz Muller. So, dito, ang example natin dito is we have the wasp at saka yung mga digger wasp. So, itong mga images na to, they have the same coloration. They warn their predators, kapag ganito yung kulay nila, they warn their predators that they are inedible. So, hindi sila masarap kainin. So, yan yung ginagawa ng mga nito. So, Mullerian mimicry is successful because the predator has to be exposed to only one of the species before learning to stay away from all other species with the same warning color pattern. So, iisipin ng predator na to that when this predator sees this kind of coloration, i-assume niya na hindi yan makakain. Now, the last one is the Mertensian mimicry, Emsleyan or Mertesian mimicry, named after by first proposed by M.G. Emsley, but it was further developed by other German biologists like Wolfgang Wickler, who named it after dun sa German herpetologist like German herpetologist Robert Mertens. So this type of mimicry is very rare and more difficult to understand. For this type of mimicry to work, it is essential that, example, eating the milk snake has an unpleasant but not fatal consequences. So ito yung example niya. So yung ang gagawin dito is they will mimic the one particular species para yung dangerous one, para the other species will assume that this particular species is also dangerous. Now, these are just some examples. These are examples of mimicry, so as defense mechanisms of various species in the wild. Now, of course, when we talk about species interaction, hindi mawawala yung mga competition. So, this has been introduced already by Sir Neil kanina. So, meron tayong two types of competition, intraspecific competition at saka interspecific competition. So, the competition occurs because may short supply of resources. So relative doon sa number na nagsisik doon. Halimbawa, analogy, we have 10 apples and 10 individuals. Each individual has 10 apples, will eat one apple. So ibig sabihin walang competition. However, ang nangyayari, in reality din naman, halimbawa, meron tayong 5 apples. Tapos meron tayong 10 individuals. So yung 10 individuals na yun, they will now compete kung sino yung makakakain doon sa 5 apples. So that's how competition occurs. So it is very relative doon sa supply ng mga resources existing in the area. Now, as long as the availability of resources does not impede the ability of individuals to survive, grow, and reproduce, walang competition na mangyayari. Pero kapag yung resources ay insufficient to satisfy the individuals, dun tayo magkakaroon ng competition. So we have two here. We have the intra-specific competition and inter-specific competition. So intra-specific competition, this is a competition of the same species. Inter-specific competition, species of varying different species. So meron tayong two types of intraspecific competition. We call it as scramble and contest competition. So yung scramble, it occurs when growth and reproduction are depressed equally across individuals in a population as the intensity of competition increases. Yung contest competition naman, it takes place when some individuals claim enough resources while denying others a share. Kumbaga, dito sa first one, this is the very typical competition. We have short amount of resources, tapos marami yung population. Now, people or these individuals will compete with the available resources. Dito sa contest competition naman, ang nangyayari dito is some individuals will hoard the resources, and yung mga weakest o yung mga may hina, of course, they will be denied of their share. So these are the two types of competition. And sadly, this is happening in our government. Okay, so interspecific competition, as I've mentioned, it is a competition between members of different species. So it refers, so we have here symbiosis. It refers to close interactions between individuals of different species over an extended period of time, which impact the abundance and distribution of the associating populations. So we have different types of interactions, and probably will not really dwell too much of this, but we have here of course, a neutral. So kapag positive, yan, ibig sabihin they both benefit. Kapag negative, it is detrimental to the other species. So we have here the mutualism, commensalism, competition, amensalism, the predation, parasitism, and parasitoidism. So anong difference ni parasitism and parasitoidism? So si parasitism, i-compare natin itong tatlo kasi pare-pareho sila, no? Si predation, the usual na prey-predator. So si parasitism, it's more of the parasite will not abruptly kill the host. So it's somehow parang it's killing me softly, yung that name. Dito naman sa parasitoidism, it's similar with the parasitism, but iba yung involved, the parasitoid. Predation, of course, abrupt yung killing. Now, to explain yung interaction, yung interspecific competition, we have Lotka-Volterra model na ginagamit to. It is a mathematical equation. It was developed by the American, si Lotka is American, Alfred Lotka. Si Volterra, Italian, so Vittorio Volterra. So they created a model in which, mathematical model, that explains the interaction of two species in a certain using the same resource. So this is the formula. Medyo mahaba yung formula nito, but will not compute for it, but it explains ang gustong sabihin nitong formula na to. Let's say for two species, when they interact with each other, it could result to 4 different scenarios. So yung first scenario, matawag kasi dito, we call it as isocline. So yun yung interaction ng dalawang species with respect to different variables. So yung first case, ang pwedeng mangyari daw, now when the species falls, first case, species 1 will always win over the species 2. So kapag laging nananalo si species 1 over species 2, of course, maubos siya. So magkakaroon tayo ng extinction. Another scenario daw is reverse of that. So si species 2, halimbawa, mas stronger siya, mas stronger siya sa species 1, so the situation could be reversed. Another scenario is it's not more of extinction, but it inhibits yung presence nung organism na yon, yung species 1 na yon, it inhibits the growth of the other species. Tapos yung isa naman, ibig sabihin dito, the organisms can coexist. Now, dito sa pangalawa naman, it is almost similar, pero almost similar, pareho yung line sila, but you can see here, nagva-vary yung pasok ng line, palabas, and palabas yung line dito. But this isocline generally explains that the both species inhibits the growth ng species. Ngayon, magva-vary sila. Yung pinaka most abundant, siya yung usually na mananalo. Okay? So these are the models created by these two biologists. So we have Lotka and Volterra. So itong Lotka-Volterra model na to, it was linearized, explaining yung prey-predator relationship over time. So they linearized this, the Lotka-Volterra model, population size. So in-explain niya, over time, ganito yung mangyayari daw. So we have the prey. If the prey is increasing, of course, yung ating prey, ay yung predator, kung mas marami sila, yung ating prey ay bababa yung kanyang population. Kasi nakakain siya ni prey. So over time, ganyan yung mangyayari. Until to ang pinaka-common model dito ay yung sheep, I think, the sheep and the fox. So, yan. If the fox is, kapag increasing yung population ng fox, yung population ni prey ay bababa. Now, kapag bumaba yung population ni fox, of course, kasi lilipat siya. Kapag naubos na yung makakain niya sa lugar, si predator na to, lilipat siya. So, mawala sila sa isang area, sa isang region. Now, magpo-proliferate ulit si prey. Now, babalik si prey, babalik si predator, bababa na naman yung population. So this is how the Lotka-Volterra model is linearized in explanation of the prey and predator relationship. Now, of course, yung ating mga species, they have their specific function and role. Kumbaga, meron silang functional position and role sa ating environment. Ngayon, anong tawag natin dito? We call it as, could still remember, yung functional position and role of an organism in an environment. We call it as niche. So we have the ecological niche. So yung ecological niche, it includes the following. So yung habitat in which the organism lives, the activity patterns of the organisms, the periods, example, the periods of during which it is active. So tulad nung explanation ko kanina sa mga birds, we have diurnal birds, we have nocturnal birds, animals that are present at night. So yan, activity that is considered in terms of niche. Then we have resources. The organism obtains from the environment in terms of food source, territorial boundaries. There are some organisms that are territorial. Ibig sabihin, kapag may pumasok doon sa territory nila, they will become aggressive. Now, the interactions, of course, the interactions of these organisms with other organisms. So yan yung bumubuo sa niche. And our niche are classified into two. We have the fundamental and we have the realized niche. So si fundamental niche, ito yung mga conditions na kailangan ng isang organism for this organism to survive and reproduce. Si realized niche naman, ito yung niche kung nasaan talaga si organism. So ito yung set of conditions na actual na experience ng isang organism. Now, si niche, hindi siya linear. Hindi lang siya linear. It is multidimensional, which means for an organism to define its niche, you're not just only considering its temperature, one dimension, that is one dimension. You're not just only considering, let's say, salinity and temperature, but you have to consider yung lahat ng factors. So it is multidimensional. So these images, it just shows that we have to get out of the notion that the niche of a certain organism just only refer to a particular factor. Now, kapag nagkaroon tayo ng better understanding of the niche, in a way, we could understand how we could conserve also different yung mga organisms na to. Kasi we could provide the set of conditions that they need. Now, on the ground, in the wild, ang nangyayari, if we have such niche, anong mangyayari kapag yung dalawang species, pareho yung niche nila at nag-exist sila sa isang area? So, ang mangyayari is, one is magkakaroon ng competition. So, meron tayong principle na tinatawag the competitive exclusion principle. That the principle that complete competitors cannot coexist. So, if they share the same niche, so ang dapat mangyari is one should provide or one should move. So as you can see in this example, so we have here these are tamalus, so thalamus and balanos. So these are what do you call this? Forgot the species name. So but these are species that found at the coastal areas. Ito yung dumidikit sa mga ships. Forgot the name. Ayan. So halimbawa, ito yung si tamalus. So kung pareho yung niche na need ni na thalamus at saka ni balanos, kailangan nilang magbigay. They cannot really coexist in the same spot. Yung parang magmi-mix sila. So ang mangyayari is they will now divide the niche. So yun na yung magiging realized niche nila. So some of the tamalus will go forward paakyat sa coast, and some will at the latter area, so sa pinakababa. So ito na yan yung tinatawag natin na realized niche ni tamalus at saka realized niche ni balanos. So yung competitive exclusion principle, it involves assumptions na this principle will exist if we have these conditions. So the principle assumes that the competitors have exactly the same resource requirements. Now, second is it assumes that environmental conditions remain constant. So yan yung mga factors natin in terms of competitive exclusion principle. Pero ang sinasabi dito, basically, if you share the same resource, hindi kayo pwedeng mag-coexist. So one should give in. So kung halimbawa, kung ang set of conditions ng isang organism provided siya sa area na to, pero hindi lang ikaw yung may fundamental niche noon, ang mangyayari, you will now separate and you will try to divide these resources ay this area, at yun na yung tinatawag natin na realized niche. So ito yung actual conditions provided doon sa mga species. Another is, pwedeng mangyari is magkakaroon tayo ng tinatawag na resource partitioning. So sa resource partitioning naman, dito yung the division of a resource and specialization in different parts of it. So remember in our discussion of natural selection, nabanggit yung adaptive gradation. So ito yan. So ang mangyayari dito is instead of competing, ang mangyayari, i-divide natin yung halimbawa isang puno. So ikaw sa taas, yung other species sa baba, isa other species sa iba. So iba-iba yung baga, pwede naman tayong mabuhay, mag-coexist tayo, pero iba yung kakainin ko. Now, ang mangyayari dito sa resource partitioning, later on, it will drives now yung adaptive radiation. Remember the Darwin's finches na example natin last time? So makita natin, may finch na kumakain ng seeds, may finch na kumakain ng fruit, may finch na kumakain ng leaves. So yun yung mangyayari. So it will now drive yung adaptive radiation. So basically, yung ating species interaction, it influence yung ating population dynamics. Kasi kung paano yung interaction nila, dadami or bababa, di ba? An example na yan ni based sa mathematical conditions or mathematical expression na dinevelop ni Locke and Volterra. So it actually influenced yung population dynamics. So how the abundance of a certain population is always affected by the other population. Now, yung species interaction, it also serves as agent of natural selection. Of course, if there are competition, and if you want to survive, your characteristics should also kailangan mag-improve if you want to survive, because it is always the weakest that will always be extinct. So it now drives yung ating natural selection. Now another is yung species interaction, it influence yung species niche, yung ecological niche ng isang species. Because in the wild, it is not just only one species that have the same resource requirements. May mga species na pareho ng pareho ng resource requirements. So the tendency, yung fundamental niche, hindi talaga na-attain. So kung ano yung niche na available, yun yung napupunta sa niche, at yun yung tinatawag natin na realized niche. And lastly, yung ating this topic, yung influence the species niche, it is very exemplified with the competitive exclusion principle. Dito naman sa drive adaptive radiation, it is exemplified by the principle of resource partitioning, wherein organisms can coexist, but they will now change the resource that they need. So yung requirement nila bago. And because of the changes na to, kailangan mag-adapt. Baga, let's say, halimbawa, dahil ang kinakain ko ay, let's say seed coated, so hard seed. So ang mangyayari doon sa seed na yon, I have to develop a beak na dapat yun yung na in a way na makakain ko yung mismong resource na kinakain ko. So these are ito yung ginagawa ng mga species interaction in the wild.